So today we want to look at creating mathematical models to represent the momentum of two objects either colliding together or exploding away from each other. What we need to know is the momentum is always conserved. For Regents physics, this is really all that's important. Sometimes there is loss due to friction or sound or heat or other energy, but we don't really deal with that in this class. So there are two types of collisions and one explosion that we deal with in Regents physics, and we're going to start with a bouncy collision, and I'm going to put this into the momentum table, and I'm going to create an equation that works for bouncy collisions, and you can use that equation for any bouncy collision and just solve for whatever you're missing. So I just need this. Okay, so for this one, it says ball A of mass 5 kilograms moving at 20 meters per second collides with ball B of unknown mass moving at 10 meters per second in the same direction. After the collision, ball A moves at 10 meters per second and ball B at 15 meters per second, both still in the same direction. What is the mass of ball B? So we know that P before is equal to P after. Momentum is equal to mass times velocity. So then we can write down our objects. We have A and B. Before the collision, the mass of A is 5 kilograms and is moving at 20 meters per second. So 5 kilograms, 20 meters per second. And then ball B is unknown mass, so we can write M2. That's what we're looking for, and it's moving at 10 meters per second. The total gets added up. So then it's just 5 times 20 plus 10 M2. And then this one on the other side is still 5 kilograms. The velocity on this side, A moves at 10 meters per second. This is after. So this is then 10 meters per second. And then we still don't know M2. It hasn't changed. And afterward, it is 15 meters per second. And it's still in the same direction. Notice I put the units here in the table so we don't have to rewrite them. So then it's 5 times 10 plus 15 M2. And we just have to solve for M2. So then it's 5 times 2 is 10, so 100 plus 10 M2 is equal to 50 plus 15 M2. Subtract over 50. So it's 50 plus 10 M2 is equal to 15 M2 minus 10 M2. So then it's 50 is equal to 5 M2. And that means that M2 is equal to 10 kilograms. Now, we can create a general equation for bouncy. Collisions. We look over here, we say this is mass 1. So we write that down, mass 1. This is velocity 1. We have that. This is mass 2. We added them together. This is velocity 2. That's set equal to the other side. This is mass 1. It didn't change. This is velocity over here, but it's velocity 1 prime. So prime, like v prime, is a short, fancy way to say after. In this case. Sometimes it's used for other reasons, but in this case, that's what we're using it for. And then it's also getting added together. So it's plus mass 2 v2 prime. Okay, so this is the general equation for bouncy collisions. And if we plug things in, we can see that for this one, M1 is 5 kilograms, M2 is equal to what we're looking for. V1 was 20 meters per second. V2 was equal to 10 meters per second. V1 prime was equal to 10 meters per second. And V2 prime is equal to 15 meters per second. And if we plug these in, it's going to be 5 times 20 plus M2 times 10 is equal to 5 times 10 plus M2 times 15, which is the same thing as what we had over here. We end up with 100 plus 10 M2 is equal to 50 plus 15 M2. And when we solve it out, we still get M2 is equal to 10 kilograms. I ran out of room, so I'm not going to go through the math again, but it's the same math that was over here. Okay, so this is the general equation here. This is not in the reference table. Okay, all right, so now I have a sticky collision. It says the diagram below shows a 4 kilogram cart moving to the right and a 6 kilogram cart moving to the left on a horizontal frictionless surface. So after collision, the two carts lock together, so they are stuck together. What is the final velocity of the two carts after collision? So let's create our table. So P before is equal to P after. Momentum before is equal to momentum after. This is mass times velocity, mass times velocity. We have cart 1 and cart 2. So then this is mass is 4 kilograms times 3 meters per second. This is going to get added together with the 6 kilograms. But this time, this is moving to the left. We're going to say left is negative, right is positive. So this is then negative 3 meters per second. The total then is 12 minus 18. That's going to equal to the mass on the momentum on the other side. So then the masses didn't change. It's still equal to 4 kilograms. But these are locking together, so the masses are added. So then it's 4 kilograms plus 6 kilograms times the V prime, the total. So then 6 plus 4 is 10. V prime is what we're looking for. So then it's 6 equals 10 V prime divided by 10 divided by 10. So then V prime is then equal to 0.6 meters per second. So there's that one from the table. Now, from the table, we can get a general equation. Whoops. So general equation for a sticky collision is going to be M1 V1 M2 V2 is equal to M1 plus M2 times that V prime. So this is the general equation. Again, not in the reference table. Okay, so then we can solve for whatever you want. You have 5 unknowns, and they'll give you 4 of them. So now we know that M1 is equal to 4 kilograms. M2 is equal to 6 kilograms. V1 is equal to 3 meters per second. V2 is equal to negative 3 meters per second. And V prime is what we're looking for. And you can plug it in. So it's 4 times 3 plus 6 times minus 3. And that's equal to 4 plus 6 V prime. So then it's 12 minus 18 is equal to 10 V prime. And you again get V prime is equal to 0.6 meters per second. Okay, so you can do either way. Table method or memorizing each general equation is acceptable. It doesn't matter which way you do it. Just know that, again, this right here is not in the reference table. Okay? So then the last one is an explosion. So in the diagram below, it says a 100 kilogram clown is fired from a 500 kilogram cannon. If the clown's speed is 15 meters per second after the firing, the recoil speed of the cannon is what? So we want to know what the final velocity of the cannon is after. So this is basically the exact opposite of our sticky situation. So now we have our table. P before is equal to P after. This is mass, velocity, mass, velocity. We have the clown. We have the cannon. We know that the mass of the clown is 100 kilograms. The velocity of the clown before is 0 meters per second. We add this to the mass of the cannon, which is 500 kilograms. And it's also going at 0 meters per second to start. They're together. So the clown is inside the cannon, so they act as one thing. So we can make that so that it's just 500 plus 100 times 0. And that's equal to the mass on the other side, which is 100 kilograms, plus the V prime of the, times V prime of the clown, and then time plus 500 kilograms V prime of the cannon. So we can look at it like that. So this is equal to this over here. So then this is equal to the clown is afterwards. That's just from the equation. So instead of this, we're going to write 15 meters per second. And that's just from this right here. Okay, so then we get 100 times 15, which is 1500, plus 500 the velocity of the cannon. Okay, so then it's going to be 0 is equal to 1500 plus 500 velocity prime of the cannon. So then minus 1500. Okay, this goes away. This is equal to that. So then it's 1500, negative 1500 divided by 500 is equal to 3, negative 3 meters per second. And this is the answer here. Now, our general equation for an explosion is going to be this right here, mass 1 plus mass 2 times V initial, V1. So it's M1 plus M2 V1 is equal to, this is mass 1, V prime 1, plus mass 2, V2 prime. This is our general equation. Again, not in reference tables, so you have to memorize it if you do it this way. So anyway, we can plug in. It's 100 plus 500. This happens to be 0 this time, and that's equal to this is equal to, the mass is 100 times 15 plus 500 times V2 prime. Okay, so then it's 0 is equal to 1500 plus 500 V2 prime. And we get negative 1500 equal to 500 V2 prime divided by 500 divided by 500 with that negative sign. Okay? Thank you.